Hello guys, in this video we are going to implement logistic regression for imbalanced data set. Now whenever we want to implement logistic regression, till now we have seen that we have taken most of the balanced data set. Now what does balanced and imbalanced data set basically mean? Let's say that if I have total number of data points that are available in my data set are 1000, okay, and let's say we are solving a binary classification problem. Now with respect to the dependent feature, let's say the number of categories will be 2. Now out of that 1000 data points, the two labels that I have, zeros and ones, the number of zeros, let's say it is 900 or 9900, and number of ones are just 100. Now here you can see the ratio is 99:1. That basically means this is completely imbalanced data set with respect to the number of output categories. Even though you solve multi-class classification, if this numbers of percentage, like based on the percentage, if the ratio is quite huge, at that point of time, we will basically say it as an imbalanced data set. Now, with the help of logistic regression also, we can solve an imbalanced data set. And there is a very important parameter in logistic regression, which is called as class weights. Class weights will actually help us to assign more importance to less number of categories that are available in the data set. So let's go ahead and let's see a practical application. Here I have imported counter. And the next class that I've imported is something called as make underscore classification. And this we have already used to create our data set. Now this same library will be using to create imbalanced data set. Okay. So I will try to execute it over here. Now over here you can see I've used make classification. And over here, you know, by default, what are the parameters? N underscore sample is there, underscore features is there. By default, n number of classes is 2, right? So number of classes means 2 basically means your output feature will have 2 classes, and that is a binary classification. So if my number of samples is 10,000 over here, number of features that I have taken is 2. Now this is also a very important parameter. Now when I'm creating this imbalanced data set, I'm making sure I'm telling them that you have to probably make 2 clusters of data. So that is the reason number of cluster per class. So for one class there will be one cluster, for the other class there will be another cluster. And then this is a very important parameter to create an imbalanced data set. So here you can see weights is equal to 0.99. When I say 0.99, this basically means that when compared to the other category, right? This let's say there are 2 categories, zeros and ones. One of the category will be 99 times more, or it will be having more data points when compared to the other category. And then I have used random state is equal to 10. So once I execute this is my X. And now if I probably write counter of Y here, you'll be able to see number of zeros are 9846 out of that 10,000 data points, and number of ones are 154. Okay. Then after that, I'm going to import Seaborn, and let's say I'm going to use the scatter plot, and I'm basically going to plot this X of zeros and X of ones, my 2 input feature. And then I'm providing my parameter, which is called as Hui over here. Now, once I provide this Y output will basically label like this. So if I probably go and execute it, here you'll be able to see these data points. Okay. Now this is pretty much easy, pretty much clear till here, right? Now definitely you can see this is a completely imbalanced data points. Now, with the help of logistic regression, how can we solve it? Now I already have my X and Y data set over here. First thing that I will do is that I will split this into train and test data. And obviously how do you do it? We'll be using a train test split. We'll be using test size of 0.25 and we'll do it. So once I execute this, you'll be able to see train test. Now this is super important, guys. In hyperparameter tuning, here I'll just write a comment, hyperparameter tuning, right? Now in this hyperparameter tuning, here you can see that I'm having logistic regression. Now you know that in logistic regression, you have a lot of parameters. So I have played with penalty parameters. I've played with other parameters. We can play with solver parameter, but there is one important parameter which is called as class weight. And with the help of this particular parameter, you will be able to play with the imbalanced data set. Now in class weight, if you probably go and see the information, class weight can be either a dictionary value or it can be balanced. If we basically say balanced, or if you just copy this and write class weight as balanced, then what will happen? It will basically consider equal importance for zeros and ones also. And this usually we can use during this scenario, during a scenario where our number of outputs are equal, right, with respect to the number of categories. But right now, since we have a complete imbalanced data set, I will try to specify dictionary. Okay. Now in our case, number of zeros are this much, number of ones are this much. So I have to give around 100 times importance to this one category, right? So what I'll do is that here I've written a code, okay, and please focus on this code. This code is super important. We are going to play with different class weight value. So probably if I go and execute this over here, and probably just write class weight, here you'll be seeing that I'll be playing with this all parameters. Here I'm saying that give zeros and 1 equal importance. Here I'm saying give 0 importance 1 10 times more importance than 0. Similarly over here 0 I'm giving importance as 1 we have to give 50 times importance. So all the combination I've actually taken it, and I will now create this in the form of dictionary. Okay, how to create this in the form of dictionary? I'll just use dict, and probably I'll use this penalty parameter, C parameter, solver parameter, and class underscore weight parameter. This parameter name should be same like how we have in the logistic regression. So once I execute this, so this will be my parameters that I'll be playing with. Now here you'll be seeing that in the left stage I will probably be applying grid search CV stratified k-fold, and I'll just provide this parameters over here. Now once I do this, I've already trained it, guys. You will be able to see that it will take some amount of time for doing the training, and you'll also be getting some warnings. Okay, now you can see on all these parameters that has got trained. Now probably if I write grid dot best params, so let's see. Okay, let me just train it once again. So here you'll be seeing that it will take some amount of time. It will take some amount of time, and it will also give you some amount of warnings. You can ignore the warnings. We can also remove these warnings. So this will be an interview question to you. How do you remove a warning? Okay, it can be, but I'll give you the hint. You just have to import one library. All the warnings will be removed. Okay, so this will probably take some time. We'll wait till the execution will get over, and after that, when I probably write best score or best params, it will basically give us the best params that is required, that it has basically selected from this entire fine tuning, but this is the hyperparameter tuning technique, right? With the help of this we are doing this, right? Grid search, grid dot fit. Okay, so now these are all completed. Now if I probably go and write best params, here you'll be able to see that this params has got selected. For this problem statement, 0 has given 10 importance, but 1 has given 50 times more importance, or 5 times more important than 0. And then penalty has got selected, then solver has got selected. Okay, so now more importance is given to 1 because in order to solve this problem, and because of this data points only, right? This data points, if I'm giving some importance, I can basically create a best fit line on top of it, and I can solve it with a logistic regression. Now here is what we have actually done it. It's quite amazing. We've got all these parameters. Now I can probably write ypred is equal to grid dot predict, and here I will basically write x underscore test and just execute it. And at the end of the day, what I will be doing is that I can basically use all the accuracy score, all the parameters over there, right? So where are all the parameters? I will copy this entirely, and before this I also have to copy all the accuracy score and all. I have to import those parameters, right? Import those libraries. So I'll say from sklearn.metrics import accuracy score, classification report, and confusion matrix. So once I execute this, here you'll be able to see I'm able to get 99% even in an imbalanced data set. So now here you can see that, guys, we have also solved imbalanced problem statement, and we have classified these data points by assigning class weights, and here you can see that we are able to get a good accuracy of 99%, and this is how a confusion matrix looks like. But with respect to precision and recall, here you can see something very like the number of data points is obviously less. The precision value is quite high. The precision with respect to 1 is quite low because obviously the number of data points are less. But 18 plus 2, right? 20 data points have been incorrectly classified. So this is how you can basically use class weights in order to classify data points using logistic regression by using class weight itself. So I hope you like this session. Yes, this was it. Just try it out again with considering different data points, and let's see whether you'll be able to solve this or not. Okay. So yes, I will see you all in the next video. Thank you.